Construction, operation, and maintenance of road tunnels in Japan. Approximately 70% of Japan's land area is mountainous, and urbanization has already progressed widely in the flatlands. Therefore, it was necessary to adopt tunnel structures, not only in mountainous areas but also in urban centers. More than 10,000 tunnels have been constructed in Japan, with a total length of approximately 5,000 kilometers. In addition, the Japanese archipelago is also prone to disasters such as typhoons, landslides, earthquakes, and tsunamis. To overcome these constraints, Japanese road engineers have developed advanced tunnel technology, not only in tunnel construction but also in operation and maintenance. We will introduce some of the Japanese tunnel construction, operation, and maintenance technologies that have been fostered by these land conditions. To begin, we would like to introduce some of the features of the tunnel design and cost estimation phase in Japan. Tunnel construction is always subject to uncertainties at every phase of the project. In particular, the equipment and maintenance systems required for the operation phase of tunnels are different from those for normal earthworks and bridge sections. Taking into account these special characteristics of tunnels, and based on Japan's experience with tunnel construction to date, the contractees are fully aware of the special characteristics of tunnels, and prepare sufficiently various standards as well as guidelines. The accumulation of this experience has led to efficient technology for tunnel construction, operation, and maintenance in Japan. You will see some of these Japanese technologies in the following slides. The Kanetsu Tunnel crosses a mountain range running through the center of Japan. It's approximately 11 kilometers long, making it the longest mountain tunnel in Japan, that required special ventilation facilities as well as reduction of the maintenance costs. The Kanetsu Tunnel adopts a model-based predictive ventilation control system, which uses traffic volume simulation forecasts to control tunnel ventilation. This system enables efficient and environmentally friendly tunnel operations, including a 50% reduction in electricity consumption, compared to the previous year, while safeguarding the environment inside the tunnels and reducing the cost. The next example is the Yokohama-Kita Tunnel, an urban tunnel. The Yokohama-Kita Tunnel is a tunnel in the city center. It is difficult to acquire a new road right-of-way in the city center. In the Yokohama-Kita Tunnel, a 50 meters underground space was used to build the expressway. In constructing this tunnel, the technology used to widen the inside of the tunnel at expressway junctions, without excavating from the surface, was adopted. This technology enables less land acquisition and less disturbance of residential environment. Ohashi Junction also makes effective use of land in the city center, where it is difficult to acquire a new road right-of-way. To connect the tunnel, which has a height difference of approximately 70 meters with the elevated expressway, a 4-layer loop structure with a circumference of approximately 400 meters has been adopted. This is approximately 1/4 the area of a normal full directional service junction type, and the junction has been entirely covered to reduce air pollution, noise, and other impacts on the surrounding environment. In addition, in consideration of the existing community and environment, the rooftop of the junction facility has been developed as a park, and is directly linked to the surrounding buildings. We will now introduce some of the safety technologies for tunnels. In particular, fires in tunnels cause more serious disasters, including deaths, than other accidents. Therefore, it is essential to have disaster prevention equipment, traffic management, evacuation guidance, cooperation with the fire service and police, and prevention measures for secondary disasters after the original fire is extinguished. As a countermeasure, various systems and equipment have been installed, particularly in long-distance tunnels. Along with the equipment, activities such as evacuation training are also carried out. To ensure a safe and secure road network, the Control Center conducts traffic monitoring in the tunnel 24/7, and also conducts maintenance inspections, on-site patrols, and other patrols to ensure that we are ready to respond immediately to any emergency situation. As a part of safety measures in a tunnel, the next example is the Tokyo Bay Aqua-Line, an undersea tunnel. Crossing the central part of Tokyo Bay, the Aqua-Line consists of a 10 km undersea tunnel section and a 5 km bridge section. The undersea tunnel section was excavated using one of the world's largest shield machines, with an outer diameter of approximately 14 meters. Special safety measures are utilized in the tunnel. An evacuation corridor has been built directly under the roadway in the tunnel, to allow users to evacuate in the event of an accident or other unusual circumstances, as well as to allow emergency vehicles such as fire engines and ambulances to drive through the tunnel. Finally, let's talk about a new technology for tunnel maintenance and operation. In Japan, we are actively using new technologies to inspect road structures, and new tunnel inspection technologies have also been developed. By filming the tunnel lining surface at speeds of up to 100 km per hour, and using near-infrared LED lighting, which is invisible to other drivers, it is now possible to recognize cracks as small as 0.2 mm wide, contributing to the early detection of deteriorated points. As demonstrated above, we have introduced some of Japan's technologies for tunnel construction, operation, and maintenance. Japanese road engineers have not only constructed tunnels to overcome various natural environmental constraints, but have also supported the smooth and efficient movement of people and goods through tunnel construction by ensuring safe operation and maintenance. We would be very happy if we could make even a small contribution to the development of road network in the world, by utilizing the advanced tunneling technology that Japanese engineers have fostered over the years. Thank you very much for your kind attention.